Designing surveys, how to sample well. Students will be able to explain the importance of randomization in study design, and students will be able to design sampling methods appropriate to a given research context. If the person conducting research has an opportunity to select participants, such as in a convenience sample, or participants have an opportunity to self-select themselves for a sample, the results will always be biased. Instead, the process for choosing individuals for a sample should be left completely up to chance. This is called random sampling. Random sampling ensures that data collected from a sample will actually represent the population, thereby eliminating possible bias. A simple random sample is the most simple way to randomly sample. The hat method might be the best way to illustrate what a simple random sample is. You would write the names of every individual in your population on identical slips of paper. Toss them around in a hat and select your sample. In an SRS, every member of the population is equally likely to be selected for the sample. That is key. Every member of the population is equally likely to be selected for the sample. In class, we'll look at how to use technology as an aid to generate a simple random sample. There are additional sampling methods that might suit a researcher's needs. For example, a stratified random sample can be used to break a population up into groups called strata, and then choose an SRS within each group. Let's take this example here. This is our fake population, and we're going to divide them into 4 strata. The first one is high school graduates. And the second one is college graduates. We have people with masters. And we have PhDs. So if you notice, I'm going to separate my population into these 4 strata. This is what each of these groups have in common. The college graduates have in common that they've all received a diploma from college. And then within each strata, I'm going to take a simple random sample of the people within that strata. Therefore, I have them people who are similar grouped together, but I'm going to be able to compare results across the strata. Again, I want to make sure that the people in each strata are similar to each other in some way. For populations that are large and spread out, an SRS or stratified random sample may be too difficult to execute. Instead, a cluster sample may be used. The populations are divided into groups based on geographic proximity called clusters. Then, a simple random sample is chosen of each cluster. Within each chosen cluster, every individual is included in the sample. Let's use this as an example. This is a map of Brooklyn, and Brooklyn is broken up into its city council districts. There are approximately 50 of them. So in this example, if we wanted to do a cluster sample, we would randomly select, let's say, 5 of the city council districts. Randomly select does not mean a person choosing their 5 favorite numbers. It means we gotta either put the numbers in a hat, pick out 5, or use technology to generate those 5 numbers. Once we have those 5 city districts, we're gonna go to each of them and sample every single person within that cluster. These clusters might be too big to be able to do that, but hopefully you get the idea that every person within each cluster that you have randomly selected will be sampled. A final sampling method is called a systematic random sample. This method works well if members of the population are in order, such as in a line. Only the first participant in the sample is randomly chosen. Then using a consistent interval, we'll choose participants after that. So in this case, every 5th person after the first randomly selected person will be selected for the sample. When sampling in large-scale projects, complex combinations of sampling methods can be used. But the building block of any sampling method is a simple random sample. However, note that the stratified random sample, the cluster sample, and the systematic random sample are different from the simple random sample in that each member of the population will not have an equal opportunity of being selected in those 3 modified versions of the simple random sample. So let's take a moment to practice and work through a couple problems together from your textbook. Go Blue. This problem is on page 231 of your textbook. Michigan Stadium, also known as the Big House, seats over 100,000 fans for a football game. The University of Michigan Athletic Department plans to conduct a survey about concessions that are sold during games. Tickets are most expensive for seats on the sidelines. The cheapest seats are in the end zones, where one of the authors sat as a student. A map of the stadium is shown. So as you can see, we have our sideline here, an end zone here, and our corner here. They want us to answer 2 questions about potential sampling methods. The first question is, the athletic department is considering a stratified random sample. What would you recommend as a strata and why? Take a moment, you can pause the video to think about your answer before we come back together. Well, a good strata for this example would probably be dividing the population into your different types of seating. So whether or not you have sideline, corner, or end zone. Why does this make sense? People sitting in the sideline probably paid a similar price as well as a corner and people sitting in the end zone. So that's your similarity. How much did they pay for the ticket? And since we're asking something about what concessions that are sold during the games, we want to be able to look at the money relationship in this problem. So the most relevant similarity between the people sitting in the stadium is going to be the fact of whether or not they're sitting in the sideline, corner, or end zone. Now the second question says, explain why a cluster sample might be easier to obtain. What would you recommend for the clusters and why? So again, take a moment, think about what your answers to this question before we come back together. So why would a cluster sample actually be easier to obtain? Well, if I do a stratified random sample and I randomly select people from each of the sections, sideline, corner, and end zone, I might end up pulling seats from all over the stadium. And the stadium might be jam-packed, so it might be hard to actually reach all of those individual people. So using geographic proximity might actually help me sample everyone that I want to sample. So how would we do a cluster sample? Well, we have about 44 different sections in this stadium. So we could do a cluster sample, randomly selecting, let's say, 5 or 6 of these 44 different seating sections. And then we would have to sample every single individual within each of these seating sections. We're going to try one more question, but this one you're going to complete independently. I want you to write down your answer thoroughly and bring this to class to check the following day. So this says, how was your stay? A hotel has 30 floors with 40 rooms per floor. The rooms on one side of the hotel face the water, while rooms on the other side face a golf course. There's an extra charge for the rooms with the water view. The hotel manager wants to survey 120 guests who stayed at the hotel during a convention about their overall satisfaction with the property. Feel free to pause the video here if you need to review the prompt for a little bit longer. Again, they're asking us to consider 2 possible sampling methods. So the first question you're being asked to answer Explain why choosing a stratified random sample might be preferable to a simple random sample, SRS in this case. What would you use as strata? So take a moment, pause the video, write your answer to this response. The second question they're asking you, why might a cluster sample be a simpler option? What would you use as clusters? Again, pause the video, take a moment, write your response to this question. When you're finished, take a break. I'll see you in class tomorrow, and we'll go over your responses.